Okay, let's take a look at drawing the reflection of an object. And this guy here is our object in a concave mirror. So here we've got a concave mirror. Here we've got our midline. This is the center of curvature. Center of curvature. And this is the focal point. Okay, so the distance from the mirror is here. The focal point is halfway between the center of curvature and this point right here. So the center of curvature is twice as far away as the focal point in a spherical mirror. This changes a little bit when it's parabolic because it doesn't have an exact center like a mirror does. But for us right now, the center of curvature is twice as far away from the mirror as the focal point. Okay, I'm going to teach you how to draw these and how to figure out where the image will be and what the image will be like. So we're going to be looking for LOST. We can also talk about our magnification. So L is the location of the image, which side of the mirror is it on, and how far away is it from the mirror. O is the orientation. Is our image the same way as our object, or is it upside down? Right? Because you look at a spoon, and your face looks upside down in a spoon. That's an inverted image. S is size or magnification. So here's our object. We have our object size. How big is our image size? And T is type. This is real or imaginary. A real image means you can project the image onto a piece of paper. An imaginary image means we can't. Imaginary images are going to be over here. Real images are going to be on this side. So anything on this side is going to be imaginary. Anything on this side is going to be real. Right. Now, we need to draw two light rays emanating from the tip of our object. So I'm going to need to choose different. The first light ray runs parallel to the midline. Now I put some dots on this paper, so hopefully that'll help you. So first line runs parallel to midline. So this is ray 1, parallel to midline. It hits the mirror. You got the little arrow here showing that it hits the mirror. Then it bounces back through the focal point. So you use your ruler, bounces back through the focal point. So that's ray number 1. Parallel to the midline, bounces back through the focal point. Ray number 2 from the tip of our object goes through the focal point. And you want to be as precise with these as possible. Through the focal point. So this is ray 2. Ray 2. Through focal point. Then it'll bounce back parallel to the midline. And try and be as precise as you can. Ooh, my ruler just moved there. Then parallel to midline. Our image is located where they meet. So our image is located right here. There's our image. And our image goes from the midline to the meet. So let's start. Let's talk about our location. Our location, this one is located 5.5 centimeters. away from the mirror. It's on the same side. Its orientation, it's upside down, it's inverted. Its size, will we measure its height? It's about negative 12 negatives 1.2. And the type, okay. The type here is we have solid lines coming together. It's a converging image because we have two lines coming together to meet it, two real lines. And so this is going to be a real image. Real images are on this side of the mirror. So we're going to have real on this side, imaginary on this side. Or on non-real, whatever you want to call it. Now we can figure out the magnification here, right? So let's look at our original image. Original image is 2 centimeters. So what is our magnification? So our magnification is equal to negative 1.2 over 2 centimeters. And we just pull out a calculator. I think this is right. Yeah, that's right. 1.2 divided by 2, 0.6, negative 0.6. Now the negative means that it's been inverted, so this would be a 60% image. 60% magnification, right? The image is 60% the size of the original. So we could write our magnification as 60%. Now, what's this little formula guy here? Well, we're going to do this little formula guy. And I'm going to take out a sticky note. And this little formula, guys, we're going to see how close we are. This formula is supposed to work for mirrors. This is a mirror equation. 1 over the focal length is equal 1 over the distance to the object plus 1 over the distance to the image. Okay, so we're going to see how accurate we are. We're going to take our distance to the object, and our object is, what, 8.5 centimeters away. Distance to the object is equal to 8.5 centimeters. And what's the distance to our image is equal to 5.5 centimeters. Okay, now let's do a little bit of math here. 1 over our focal length is equal to 1 over our distance to our object plus 1 over distance to our image. 1 over 8.5 plus, so 1 over f, plus 1 over 5.5. Okay. Now I do that on my calculator. 1 over 8.5, and I'm going to get my good calculator out here. So I'm going to do 1 over 8.5, 1 divided by 8.5, plus 1 divided by 5.5 equals. So 1 over f is equal to 0.2994, etc., etc. Now to solve this, I just swap this. 1 over 0.29 dot 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 is equal to f. So I do 1 divided by my answer. I get 3.3. This means my focal point should be 3.3 centimeters away from my mirror. Well, let's see how close it really is. My focal point is 3.5 centimeters away. That means I'm pretty close. This is pretty accurate. See, it's right here, 3.5. And according to my calculations, it should have been 3.3 centimeters. So that means, so this is my calculated in theory. My actual was 3.5. That's not bad. That's pretty close. That means we're pretty accurate with this. All right. So now in the second mirror, which we'll do the second mirror in this video, then we'll do the next two mirrors in another video, just so these videos don't get too long. In the second one, we've moved the object between the center and the focus. So let's see what happens when we move the object between the center and the focus, and we'll compare it to this one when it's outside the center. Okay, so right here's our center of radius and our focus. We do the same thing, right? First ray 1, parallel, hit the mirror, down through the focus. That's ray 1. Ray 2, through the focus. Hit the mirror. Whoop, dropping the pens here. Parallel to the midline. Where is our image located? Right here. Let's do our LOCT, our LOST, location of our image. So here's our image. I've got it at about 8 centimeters. Orientation, it's inverted, it's upside down. Size, well, it's enlarged, right? I've got it at 2.8, negative 2.8 centimeters. Type is real. Now we can figure out our magnification, right? Magnification is equal to, let's see how tall this original one was, 2 centimeters. Sorry, I gotta put the image on the bottom, on the top. Negative 2.8 centimeters over 2 centimeters. And I get 1.4, negative 1.4, or magnification of negative 140%. The negative here just tells me, sorry, you couldn't see that. The negative here just tells me that it's been inverted. Okay. So let's do our math and let's check to see how accurate we are. All right, so I've got 1 over my focal length is equal to 1 over distance to the object plus 1 over distance to the image. 1 over my focal length is equal to 1 over my distance to the object. Oh, I got to measure that out. I got 5.5 plus distance to the image, 1 over 8.0. And I do that math. 1 divided by 5.5 plus 1 divided by 8, and I get 0.3068 dot dot dot, keeps going. 1 over 0.306 dot 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 is equal to my focus, so I do 1 divided by my answer. 3.3 centimeters. Let's see how far away our focus is. Our focus is 3.5 centimeters away. We're pretty close again. That means our diagram is pretty accurate. All right, so now let's see what happened between these two guys. So we took this object, and as we moved it in, as we moved this object in to here, our image moved out and got bigger. See, our image moved out and got bigger. What do you think would happen if we put the object right at the center? It's an interesting question. I want you to think about it. Look at what's happened here. All right, in the next video, we'll look at the next two examples, where we put the object right at the focus, and then we put the object inside the focus where things get weird. Right, we'll see you in the next video.